signing up to attend our October meeting this month. We want to do a few chapter announcements before we start with our esteemed speaker, Stephen Shang. This is Steve Spence, your president of SEAOSD. So we have a few announcements that we want to go out of that we have here. Let me pull up my notes. So I have on your screen here, November 17th at noon, we have Bo Dowswell, who's the T.R. Higgins Lecture Award winner. He's going to be presenting on Sorry about this, guys. I've lost my notes in the screen. He's going to be presenting on his winning lecture this year, and it's not on my screen here, so I apologize. We have on November 10th, our existing buildings committee is doing their regular monthly meeting. So if you have any interest in meeting with the existing buildings committee, I would reach out to Peter Maloney, our chair. That's not on our screen. I wanted to let everybody know that our December 15th meeting is a joint meeting with ASCE, and we're going to be doing a presentation on this on the SoFi Stadium. It's a very exciting project. Raphael Sabelli from Walter P. Moore will be speaking about the structural aspects, and we'll also have representatives from the civil and geotechnical teams. So we're really excited to have them all present at our December meeting. So please put that on your calendar. Christmas, but December 15th at noon. We also wanted to remind everybody that the SEAOC convention has gone virtual. It is occurring from December 2nd to 4th. And if you want more information or to sign up, you can sign up at convention.seaoc.org. We also our 2021 convention. It's the San Diego chapter's turn to host, and we are requesting any volunteers if you're wanting to get involved with the convention planning for next year. Please reach out to anybody on the board, and we'll put you in contact with our convention chairs, which are Mike Brond and Steve Kerr. With that, I'd like to hand it off to Bo to introduce our speaker.
Okay. Thanks, Steve. Is my audio coming through okay?
Yep.
All right, good. We're excited to have Stephen Shang with us today. Stephen is the CEO and co-founder of Falcon Structures, a leading manufacturer of shipping container-based structures. Under his leadership, Falcon has created safe and quickly deployable container-based structures for virtually every industry, seeking a better way to create functional space. To date, Falcon has produced 1 million square feet of container structures. Mr. Shang is an industry ambassador, advocating for the safe use of shipping containers for container-based structures. He serves on the Texas Industrialized Building Code Council and the Modular Building Institute's Board of Directors. And achieve sensible standards and building codes for using shipping containers as building materials by working with the International Code Council, the ICC. Stephen is a graduate of the University of Texas at Austin and the Massachusetts Institute of Technology's Entrepreneurial Master's Program. He and his family live in Austin. And so Stephen, thanks again for doing this for us today, and take it away.
All right, well, thank you, Bo. It's a pleasure to be here with all of you. Today we're going to be talking about navigating the building code for container-based structures. And I don't know what the protocol has been in this in the past. If you have any questions, I'm sure you can jump in. If I don't see your hand raised, just feel to jump in and kind of cut me off or do whatever. But we've got a lot of content to cover today. I think one of the important things about who I am is who I'm not. And one of the things, I'm not a structural engineer. You guys are way smarter than I am. I actually got my degree in electrical engineering of all things, but I can't even jumpstart a car. So good luck today. But today, I'm hoping as you listen to this, there are a couple of key things you'll take away. One is that there have been some major changes to the building code that will help give guidance how to safely build container-based structures. And then secondly, with those changes, I'm hoping that this will give you a path forward on getting building container-based structures permitted and built. One of the questions I had for you guys is there anyone in the audience who's one of my competitors who's secretly spying on me? Can't tell with all the icons with the 2 initials, but I'm guessing not. So let's see. So this is actually part of our Container 101 course that we offer to building code officials, but we also do this for structural engineers and architects who are getting their arms around containers. And you can see we definitely have an introduction section. Today we're covering point number 2, but then we've got a technical primer for shipping containers that talks a lot about how containers are built, and then common details in container-based structures like how they come together and all that. And then last but not least, with modular construction, there's a huge amount of coordination. So we talk about scope gaps and overlaps, who does what. But today we're just covering number 2. So from an industry context standpoint, I guess unlike a live audience, I can't ask you guys to guess, but anyone want to just kind of conjecture in your mind how many shipping containers are around the world today? And the number is anywhere between 15 to 30 million shipping containers. And repurposing these containers, as you all know in San Diego, it's a multi-billion-dollar industry, and it's growing fast. It started out just being storage container rentals to job sites, and that in itself is about a $2 billion a year industry. And then you see single unit structures, ground level offices, equipment enclosures, pop-up retail. You've probably seen them in your hometown. But recently, in the last five years, we've seen the emergence of what we call multi-unit structures. So things like schools, multifamily, offices, and even stadiums being built out of containers. And the problem is with all these this market expansion, there's a huge question around public safety. Local jurisdictions and state administrative programs, they're really more reactive than anything else to this growing trend of shipping containers and how to use these in IRC and IBC occupancies. And they're way behind in terms of the regulations and compliance. And so what's happened over the last 5 years is this patchwork really emerged. These different regulations. I know San Diego has some. They create potential conflicts even with state programs. Sometimes they duplicate, and it makes it really hard for developers and owners and design professionals to really figure out what to follow. And at the end of the day, the local authorities having jurisdiction, what they're looking at is just, how do we address these? How do we make sure that they're safe? And so it's just a really confusing situation. Now, just for clarity, I've had to say this in the past, but these heads here, from Genesis are not meant to represent building code officials, but rather the state of confusion that's currently in the permitting process for container-based structures. But at the end of the day, I think one of the things that keeps me up at night as an industry person is, could you imagine if there were headlines that look something like, construction worker trapped inside of container office for 72 hours due to poor structural welds, or retail employees electrocuted in climate controlled shipping container, wiring was not to code, or even worse, this is the worst nightmare, cantilevered container structure collapses, there was no structural engineering approval. And these are the kind of things that if they did show up in the news, it would be a really big black eye, if not kill the container-based structures industry. So today we'll talk a little bit about the background of how all this kind of came together, but we'll also talk about 3 major pieces of code, I guess you could call it, that were published in the last couple of years, the guidelines, the Building Code Action Committee, and then AC 462. And hopefully we'll have some time at the end to just answer any questions that you may have. So from a background standpoint, in 2016, we started to recognize this need. We started our business in 2003, and we had slowly gotten more and more into container-based structures. We have a term here at Falcon, we call it box fever, like more and more people were getting box fever. And so I went to the Modular Building Institute and I said, hey, look, we need to establish a container task force because containers are rapidly becoming, one of the primary ways to do modular. So I chaired this task force along with Mike Wilmot, who was on the East Coast of Maryland. But then in San Diego, Ralph Tavares, he stepped up to the plate and was on this task force. And you can see there's an assortment of different container companies, as well as third-party inspectors and design professionals on this task force. And we invited them all down to Austin for big kind of, barbecue kind of thing. And what we did was a meeting of the minds where we came together and we wrote this industry white paper. This is available on the NPSA website. It's also available on the MBI's website. But this was published in June of 2017, and you can see the areas that we covered. And we definitely talked about an overview of the industry, but we talked about the current code environment, and we were not gentle about it. We're like, look, it's really messed up, and everyone's confused, so how do we solve this? And so one of the key frameworks we set forth was really segmenting the industry actually into 4 different segments. We talked initially about structural integrity, we talked about the toxicity of these containers, and then we really took it all and summarized it. And it became, here's what we recommend for each segment. Now, this document's kind of out of date by now, but more than anything, what this did for us back in 2017 was it provided a calling card with code officials and really let them know that, hey, look, we're serious about getting containers within the IBC and IRC frameworks. And so as part of that, we executed this memorandum of understanding in April of 2017. And this was between the Modular Building Institute and then the ICC, the International Code Council. And it laid the groundwork for relationship. And the primary purpose of it really was to streamline the use of offsite construction. But what the ICC was really looking for is like, hey, how do we go about working with containers? Because that was the burning fire for them. So there in that picture, you see the guy in the pink tie. That's Dominic Sims. He was the CEO of the ICC at the time. And then to his left is Tom Hardiman, the executive director of the ICC. Now, I think all of you guys who are on this call know, kind of what the ICC does or who they are. But we had to create this just simplified code ecosystem of, okay, look, there are these building codes and they're published every 3 years. I mean, back when I got into this in 2016, 2017, I thought building codes was like, you couldn't build like, adult entertainment thing next to a school, but come to find out that's more like zoning, but really trying to understand what building code was. And so we pushed forward on 3 fronts. One was on the guidelines, which are not part of the code, but they advise the code. And then the Building Code Action Committee that actually goes in and actually affects change in the code in the 3-year cycles. But then off to the side, they have this ICC evaluation service. And within that, they have acceptance criterias. And not included in this slide was a recent effort that I undertook, which was working with the IAS, the International Accreditation Service, which is part of the ICC as well. And what we're trying to do there is really come up with an accreditation criteria for container-based structures. But really, at the end of the day, this is how code felt to me when I first got to get involved in it. Hopefully, you guys are involved enough that that you don't feel like this. But key takeaway number 1 is like, look, the ICC is a good organization, and they're dedicated to building these model codes so that we can build safe structures. And most governments trust the ICC suggested codes and they adopt them into law in their jurisdictions. So let's move on to the ICC guidelines and what we went about doing there. The first one, we formed this task force in June of 2017, and it was chaired by a guy named Mike Pfeiffer. He was the SVP of Technical Services at the ICC. And he really rolled up his sleeves and did a lot of homework. Tom Hardiman, the director of the MBI, was the chair. I was on it. Hala Jawad, who was with Radco in Long Beach, she was on it as well. She has since passed, but she was a great contributor to that. We had members from the National Portable Storage Association, as well as several heavy hitters from the ICC. And really what to do is to create a guideline on how to use shipping containers and dispel some common myths. So it's not meant to be a regulatory document. It didn't go under as much scrutiny as really changes to the building code. And it was approved and published in March of 2019. When I was giving my talk at the World of Modular about the update on this, they allowed us to release this document to the general public at that talk. If you're interested in getting this, if you just Google ICC G5 2019, you'll get directed to the ICC store. And I think you can download a PDF version of it for like $20. If you want to buy a hard copy, I think it's $25. But this really has become a key piece of container-based structures compliance for a lot of code officials. So that's key takeaway number 2. But really, let's talk a little bit about what really is in this document before you go out and buy it. It definitely provides an overview. It talks through some of the segments as we had proposed, And then it goes through current code requirements. And this is where the real juice of this is there some reference to reference standards in here, and it talks about the interiors, really concentrate on those. But again, the problem, you know, it's a growing trend. HJs are reacting and behind, and the patchwork of regulations, like we talked about, is really conflicting, if not duplicative. What I've found is that in using this document, and I have 10 copies here at Falcon, is when I go visit with building code officials and I present them with this document, this problem identification actually builds a great deal of rapport, right? They're confused, but they don't want to admit it. And showing them that, hey, look, this problem is not just your problem. This has been happening around the country, has made a huge difference as far as talking with the code officials. So as far as the industry segments goes, this was a framework that we set forth in the white paper, and it stuck with the guidelines. And so what you see, there are two axes here. One is whether the container-based structure is temporary or if it's permanent. And then secondly, is it a single unit structure or if it's a multi-unit structure, right? So some examples of this, like in segment 1, a temporary single unit office would be what you see on job sites. It's a mobile ground level office that construction workers love to work out of. And so there you see an example of it. But then a type 3, this is here in Central Texas, we built a poolside cabana out of the shipping container. And you can see there's no electrical, no HVAC, nothing really in there besides some structural kind of calculations. But that would be a type 3. It's a single unit, but it's permanent and it's open to the public. And so one of the cases that we start to make here is that, hey, look, a type 3 container should go under a lot more scrutiny than a type 1 container. And building code officials seem to really get on board with that. You take it a step further and you look at segment 2, and this is a tailgating container that was built in Florida. But there you have a temporary structure, but it's comprised of several containers all put together, and even one of them is vertical, right? And so the case there is that this segment 2 should probably go under more code scrutiny than a mobile office. But then you go all the way to segment 4, and this is a stadium that we built in Ohio. It's made up of 125 containers. I think you can see that it's 3 stories high. And not only that, you've got multiple containers that are turned on end as columns. And so this, for all intents and purposes, yes, it's made out of containers, but it needs to go under the full scrutiny of the building code. And so key takeaway number 3 is really, as you talk to your code officials, as you try to get code compliance, that shipping container building code should not be a one-size-fits-all solution. It doesn't make sense to regulate these as one industry or as one product, but to really look at it in multiple different ways. So the first consideration then is, is it a temporary structure? And as you all know, temporary in the building code is not very clearly defined, but it does say, look, you could probably say that it's temporary if it's 180 days. I believe in San Diego, it's more than that, or it's when the title is being passed from owner to occupant. But anyway, when things are temporary, the building code official doesn't have to conform with the full extent of the building code, but does have to consider public health, safety, and general welfare. And so this is something that's very explicitly stated in these guidelines. Now, when it comes to permanent structures, this was actually bad news for the industry back about 3 years ago, because what it says there is containers like any other building or structure are required to comply with the codes. And it's like, okay, that's great, but if you don't say anything in the codes about it, then how do we comply with the codes, right? So it goes through these non-structural requirements. These are all different chapters or pointers to the IBC. But then if you look at the structural requirements, right, it starts to list out, and you guys are very familiar with these chapters, the general structural design, special inspections, soils and foundations and steel. And then it says a little bit about, whether it's multi-unit or single unit. And so it poses this statement: one of the challenges for code officials is the lack of information on material properties and specifications related to the steel elements of a container. It's like, well, thank you. That doesn't do a whole lot for us, because that's a challenge for the industry as a whole. And if the guidelines stopped there, then we would all be in trouble, because it really wouldn't have done a whole lot. But this is where it starts getting exciting, if building code can be exciting, is that it starts to point to what's called the CSC Safety Approval Placard. So if you go to any container and you look at the front of the container on the left-hand side on the left door, you'll see this kind of silver plate. And what this is it's the CSC plate, okay? And it's important because the guidelines goes as far as saying, look, code officials can rely on this data plate. And it even goes as far as, hey, look, without this data plate, code officials may just outright reject the container. So what I tell folks in our industry as we're doing this, these CSC plates are like your mattress tag. Do not remove them until you take it home, kind of thing. But really, what's on this data plate? Well, there are really 3 reference standards that are on this data plate. And remember that it says that code officials can rely on this data plate, so therefore, by inference, that you can actually rely on these reference standards. Now, the first one is the CSC, and the CSC is an international agreement that resulted from the 1972 convention. It was the International Convention for Safe Containers, right? And so it talks about countries who are also referred to as contracting parties, and it sets the standard that containers are designed, and it refers to the ISO, the International Organization. And it also goes as far as saying, look, we need to have a regular safety inspection protocol. And so that means that every 5 years, these containers need to be inspected. And this was signed in 1972, so it's 47 years old. The reason that I know that because I was born in 1972. And it really sets the stage for really the expansion of international shipping, because it really did make all the countries pretty consistent on how they would use shipping containers. So that's a really good reference standard. The second one is when you go to the ISO, it actually refers to 3 different ISO standards. 1497-1, which is the performance standards of the containers. And so that's talking about static and dynamic test loads. It also goes into 6346, which is really how the container is identified, what needs to be included on the safety approval placard, and then ISO 668, which is the dimensional requirements and tolerances of the construction of containers, right? So the ISO really provides a lot of the guidance for how these containers are designed, how, what kind of strengths they have to have. But then the building code official asks, well, how do we know that it was built to the ISO standards per the treaty that was signed? And that's what those 3 logos there, American Bureau of Shipping, Lloyd's Register, Bureau Veritas, those are actually known as classification societies. And what they do is they go into the factories where these containers are being produced. They check out the mill certs and everything else with the steel that these things are being constructed out of. They test the containers after they're built. And so there are actually, I believe there are 12 of these classification societies that are around the world. And that's what their job is to make sure that these are being built to ISO standards. And so if a container manufacturer passes all of these while building a container, they get that little silver plate, the CSC safety approval placard right there. And what you also see there is that they get a unique identification number. So if you look under, I don't know if you can see my cursor, but where it says owner's number, it has a 4-digit prefix, which is really the shipping company or the owner of the container. Then there are 6 digits that are kind of the unique identifying number. And then the 7th digit is really a check digit. Back when they used to do a lot of manual data entry, you would punch in 300119 and it would spit out a 5 based on some algorithm that said, okay, you keyed this incorrectly, and you can compare the 5 to make sure that you didn't have a data entry error. So one of the things that you see then is if you were to take all these ISO standards as a structural engineer and you've looked at the ISO rigidity test, you can actually demonstrate to the building code official that, look, based on the ISO rigidity test, this translates into that a container should be able to withstand 180 mile per hour winds without warping, right? And that's when the building code official starts to understand how strong are these containers and how exactly they work. So key takeaway number 4 is that the shipping container industry is already testing the structural integrity of each container, and that the building code official can actually take these tests and translate them into building code and therefore pass them as building elements. The second part of the juice that's in this guideline is around toxicity, right? I don't know if you guys have used much containers, but inevitably the question always comes up, what was stored inside these containers? How do we know there weren't dead bodies or nuclear bombs? And trust me, I've been in code meetings where they bring that up. Or they'll refer to an article in a website called treehugger.com that says, hey, look, it says here on treehugger.com that these floors are impregnated with these super toxic chemicals, and if you're inside a container for more than 24 hours, you'll die, kind of thing. And so we wanted to address that in the guideline. I've been officing out of a shipping container. In fact, I'm sitting in a shipping container right now, have been officing out of shipping containers for 17 years. And aside from this really strange rash, I'm just fine. So as far as the question of what was transported, again, there are a bunch of different international agencies that really regulate the use of containers. And so the first one is the International Maritime Organization, and that's part of the United Nations. And what you see there is that if something is radioactive, if it's flammable, if it's toxic, whatever it is, it has to have a placard on that container that denotes it as such. And the people that really enforce this are the Coast Guard, the EPA, and the Customs and Border Protection. But if you take all this kind of traceability and everything that's happening with shipping containers and what's being transported, the conclusion that the guideline draws is that it's highly unlikely that a contaminated container would make it into the marketplace. Now, as far as the floors go, this is more chemical engineering, I guess. But we hired a toxicologist called TRC out of Windsor, Connecticut. And in September of 2017, they published this paper, which was based on a peer-reviewed toxicological literature. I think I'm saying that correctly. Anyway, so we as an industry, we were able to gather what are the common wood treatments that manufacturers of containers are using in the floors. And so we found these really scary terms like bacillium, meganium, rhodalium, and tellurium. And yes, terrifying as it was, when TRC did the toxicological review. I'm sorry?
I have a question. Do we have an email called admin@danceofwar? No, shit, that's not an email. Shit.
Okay, I'm not sure if that was a comment for me, but based on the toxicological review, what they found was that these active ingredients are actually approved for use within consumer products, such as food crop or ornamental crop pet insecticides, and they're also used for veterinary applications. And unless you as a human being are ingesting these chemicals in huge quantities, they're not gonna poison you, right? So case closed on that. Now I'll tell you, once you think you have something that's idiot proof, they're gonna create a bigger idiot. I was doing this presentation to an industry group, and I see this hand go up in the back of the room, and they said, hey, look, I understand we're not really ingesting these floors in huge quantities, but our guys take a lot of the scrap wood and they'll actually barbecue with them. Do you think that's safe? I was just like, sorry, I'm not an expert in that. But the chemicals are safe, and if you need that, go to the guidelines, show that to the code official, and it should be okay. If you actually need a copy of the report, again, I think the NPSA and the NBI have the report for public download on their websites. But as with anything the guideline goes through, as with anything that's repurposed, make sure you clean and sanitize it prior to reuse. And so the quality program of the manufacturer should have some kind of cleaning standard. So the interiors of the container are okay. That's key takeaway number 5. And then it goes through a lot of frequently asked questions. I don't think we have time to go through these today, but just know that they're there and they are quite relevant. And I think that it's good for folks to refer to. So I'll pause right there before I go to kind of the work we did on the Building Code Action Committee and see are there any questions around the guidelines. And I think we have time to take one or two.
Stephen, they had posted. We were having them post their questions in the chat, so I'll read a few of them off to you.
Oh, perfect.
Michael Braun asks, in terms of the millions of shipping containers around the world, is there an excess of shipping containers due to less need for shipping containers for train, ship, truck transport? Is the excess driving the need for repurpose it, or is the industry driven more by the effectiveness of fast on-site modular construction?
Yeah, great question, Mike. Thanks for that. What we are seeing is it's because of the trade imbalance. So the U.S. is a net consumer, and so what's happening is these containers are stacking up in the port because it's cheaper just to keep them there and store them there than to deadhead them back to the country that's exporting product.
Okay. Second question is from Kyle Wilson. What typically happens to a shipping container that's not repurposed by a developer? Oh, you just answered that. What happens to a shipping container that's repurposed as a temporary structure? Does it undergo a third life cycle?
If you can clarify, Kyle, I'm not understanding what the third life cycle is. I would say it's probably the second life cycle of the container, where it was started out in shipping and now is being used as a storage container or some kind of a building structure.
Hey there, Stephen. This is Kyle Wilson. Just wanted to clarify on the third life cycle question. So, like if a shipping container is repurposed for its second life cycle as a temporary structure, And then after its temporary use of 120 days, and then it's not going to be used anymore as a temporary structure, what typically happens to that container after the fact?
Yeah, so typically what you see with the more temporary uses, those are being propagated by a lot of the equipment rental companies. So we used to have one here in Austin, and so we would rent them out to a construction site for, like you're saying, like 120 days. And when the job's done, the containers get picked up and hopefully not brought back to the yard, but shipped out to a different job site, and people continue using them temporary, almost like back in the days when we had VHS and DVDs, like a media rental company. Does that make sense?
It does, yeah. Thank you very much.
You bet. And I'll say this too. I mean, from an equipment rental standpoint, it should give you some idea of the speediness of these containers. You know, we were able to depreciate them at about 1% per year. So, I mean, it really is a long-lived asset. And I think the useful life was 25 to 30 years. And then after that, you could sell it for like 70% of its scrap value. Sorry, of its original value.
We have one more question, but I'm going to have Jacqueline Shore explain the acronyms that are in here because I'm not entirely sure. But she says, is HCD involved in the CSC approval?
HCD is the Housing and Community Development who oversees the modular building program in California. They are not involved in CSC, but they do accept the CSC plate for a lot of the reference standards. And so to go through their program, you typically just show them that the container has a CSC plate that's valid, and it typically works. And I think HCD does a lot of reliance on kind of the design professionals and design consultants that are signing off on it.
Thank you. That's all the questions we have so far.
Okay, well, let's dive into the BCAC then. And yeah, please, if you have questions, I think that's a great way to do it. Just go and chat, and we'll try to answer these as we go, because this is a lot of dense information. So with the Building Code Action Committee, let's see. So again, where this lies is this is the group that actually modifies building code. And so code is published every 3 years, and so these BCACs are actually very busy over those 3 years. And so in October of 2016, the ICC initiated this Building Code Action Committee, and then they caught wind of what we were doing with Memorandum of Understanding. So we launched this BCAC in June of 2017. And so Jonathan Humble, who's in Connecticut, he's a top guy at the American Iron and Steel Institute. He chaired this committee. The guy, I mean, total code geek genius, just amazing what he was able to do. Tom Hardiman was on it, and Knowledge Awad from Long Beach. I was on it, and then Trong, I can't remember his last name, a building code official in Long Beach, California, was there. And man, we had 3-hour conference calls every 2 weeks, and it was just brutal, right? I mean, our first conference call around defining a shipping container took 9 hours, and we finally settled on a definition from Wikipedia. So, you know, it was definitely a slog, but a lot of good came out of it, because by April of 2018, they had the code hearings, which really gave the preliminary nod or opposition to the changes to the building code, and we actually won that 14-0. Then they had their annual conference in August of 2018, so later that year, and it passed 264-7. And then the final vote was in February of 2019, right before the guidelines were published, and the ICC ratified it 470-12. So the good news on this is that if you look in the 2021 IBC, there is now an amendment to Chapter 31 that includes shipping containers for the first time in the building code. So let's spend a little bit of time just to talk about what exactly is in this Chapter 31. And if you want to get your hands on a copy of this, I don't think the 2021 code books have been published yet, but if you get the guideline, it's in the appendix of the guideline, so you can read that through in detail. But the first one is that really talks about scope, right? And so again, there's the definition of what a shipping container is that we took 9 hours to debate and finally come to. But yeah, it's a shipping container. But there are certain exceptions that you can't apply Chapter 31 to. The first one is, look, if a building was previously approved under the International Existing Building Code, Chapter 14, it doesn't fall within the scope of this document. That makes sense. If you're actually using it for stationary storage battery arrays that really comply with the fire code, Chapter 12 of the fire code, cannot use this. If you're listing it as equipment, where like a lot of the equipment manufacturers are putting generators or servers within these containers, that doesn't apply. And I believe there's a fourth exception now as well that if it's temporary housing for experimental equipment, you can't use this Chapter 31. But everything else is usable. And so if you look at the first kind of part of this, again, it points to the CSE data plate, right? 3114.3 refers to the data plate. Containers must have a data plate, and it's only permitted to be removed when it's been repurposed. And even then, you need to keep a copy of it just for a paper trail. And then it goes through like the other one, and it kind of throws out some pointers to the existing code, right? It has to follow all these different sections of existing code. And again, if it stopped right there, we'd be in a world of hurt and really didn't accomplish a whole lot. But here's the fun part of this, is that there are actually exceptions in this Chapter 31 for single units. And that was the big win that we were able to get on this. One is around roof assemblies. And then one exception was around the detailed design procedure that's being prescribed in the building code. And it actually throws out a simplified design procedure for single unit containers. So what about the roof assemblies is important. If you go through the building code, you'll see that most roofs need to have a 2% slope on them. If you look at the top of a container, there is no 2% slope on these things, but they do shed water, right? It's actually a convex roof. It's got some ribs in it, so when this thing is on the open seas and it's raining on it, it doesn't kind of take on water. And so what we were able to get into the building code is that, look, if it's a single container and it's not put up against any other structure, you can actually exempt it from the roof requirements of the International Building Code. As far as the simplified design procedure, right, it actually is good, but it has some limitations, right? There are 4 limitations. The first one is it can't be in contact with other containers or structures. The second one is that all the top and bottom rails of the containers, the corners and the columns, cannot be notched and they cannot be removed. And then the third one is that it has to be horizontal with the floor at the bottom. And at first I thought that was kind of silly, but then I thought about all the containers we've built over the years that were vertical or even diagonal. So this one made a lot of sense. And then it needs to be in seismic design categories A, B, C, and D. And I know that severely limits things for California, but that's definitely in there. And then what happens is if you fall within those parameters, you can use allowable shear values for wind design, for seismic design. And so here you have kind of the assumptions for shear walls. And you guys know way more about this than I do, but I was happy to get this in there that we actually had some documentation around what we could use for the shear walls. And then it also gives allowable strength values for the different types of containers. So as you go down kind of that second column from the left, you have the different container dimensions, and typically it's a 40-foot or 20-foot containers. Then it goes through the height, and so it gives an allowable shear value for the sidewall, but then also for the end walls. So these can all be used in kind of designing single unit structures. And so one of the questions that came up as we were kind of discussing this is like, well, that's great, but most containers that are being used as repurposed shipping containers or second life, they're not just containers, right? We're cutting out windows, we're cutting out doors, we're putting AC holes in them and all that. What good are these shear values if we have to make all these cuts and you can't really use it once it's been cut? And so we created these conditions that said, look, you can still use these shear values within these following modification conditions and still use those values. So the first one is the biggest one, is that the openings have to be less than 50% of the length or the side of a container wall. So if it's a 40-foot container, you can cut up to 20 foot of the openings out. You can also cut out 10 foot, leave 10 foot, cut out another 10 foot and leave 10 foot. You can even go to 5 feet. But then we thought, you know what, people might get a little crazy with that. So in order for a wall section to be actually considered in that calculation, it has to be more than 4 feet. Now, if you do cut out an opening, you have to create a boundary element that takes the load from kind of the roof of the container all the way to the bottom. And then the openings do need to be framed. Now, a lot of times you'll see if you're doing like a mini split unit or you're putting in some kind of a duct, there needs to be a penetration. So does this get counted into the openings? And we thought, you know what, there's small enough openings. Let's go and say there's one penetration for these types of utilities every 8 foot in length. And then the last but not least one is that, you see a lot of architects opening up the doors to create more texture to the container. But that really does compromise a lot of the structural rigidity of it. So we said, look, the end walls have to be closed and welded shut. So, it's in the 2021 building code, and you get a lot of this like, well, in Phoenix, Arizona, we're still on the 2009 building code. What good is this going to do us? In most jurisdictions that I talk to, if the building code official goes to the current version of the building code that they're on, and there's no guidance for the particular structure, they can actually reach forward in the building code and actually grab something like from 2021 and bring it back to the present. And so that's why this is helpful for design professionals and people seeking to work with the building code community. So key takeaway number 6, the IBC incorporates the shipping containers into the building code for the first time. It's definitely limited, being that it's one container. I was trying to get 2 in there when I was on the committee, but the philosophy of the committee was, hey, look, let's get the camel nose into the tent and at least get something in there so that we can build upon it for the future. So any questions on that before I move to AC 462? You guys still all awake? No, this is really invigorating stuff.
We've got one question in here. For seismic design, has there been any work done to determine an R value for the structures? Any FEMA P695 investigations?
I do not know the answer to that. I'm not even sure I know exactly what the R value is. I think that's the response modification coefficient. Yeah. I can read those words, but yeah, I don't really know what that is.
And that seems to be an awfully low R.
There you go. See, I didn't know if low is good or bad. Maybe it's like golf. The higher the score, the worse. Anyway.
Not when it comes to seismic design. All right, here's another question. What's the maximum penetration size for an unframed duct opening?
I think I don't remember off the top of my head, but I think it is. I think it's a 6-inch diameter. I've got my handy dandy reference book right here. I can find out and get back to you. I'm not seeing it right now, but it does go through and specify how big these things can be. Oh, sorry, yes. So 3114.8.5.3 has a section 5 that says a maximum of 1 penetration not greater than a 6-inch diameter hole for conduits, pipes, tubes, or vents, or not greater than 16 square inches for electrical boxes is permitted every 8 feet.
Okay. And there's the third question. It's not on there because it's my question. This height limit, is that the pretty standard height for a shipping container? Is about 9.5 feet?
Yeah, there are 2 heights of shipping containers that are used in shipping. One is 9.5 feet. That's called a high cube shipping container. And then you have your standard shipping containers that are 8.5 feet. And it's harder to build with 8.5 feet because of the height minimums in the building code.
Okay. Well, that's all the questions we have currently on the chat. Oh, here, okay. One more.
Okay.
Okay, so, well, the question is from Reza Murad. It says, since there's no current IBC 2021, said that we can find the specification on the appendix of ICC GS 2019.
Yep, it's actually G5 2019. GS is a fancy.
Yeah, sorry, I misread it. Yeah, yeah.
But yeah, it's definitely in the appendix of this. I think if you Google just Chapter 31 of the 2021 Building Code, there are enough kind of working drafts out there that it should give you the flavor of what's actually in there without having to buy this.
No.
All right, well, let's talk a little bit about AC 462, and then we can do some more Q&A. And so, again, the ICC, they do an evaluation services program, and they accept building materials between code cycles. And so what they did was they created acceptance criteria number 462, and this was published in February of 2016. And the question, when it really, came out, there were some positives to it, but when it came out in the industry, I mean, the industry threw up all over this document. One was we were surprised, and as you read through AC 462, it was like, are they talking about all shipping containers need to be purpose-built containers, meaning that they've never been used in shipping, but they're built to a certain specification? Or do we have to go to China and have the factories in China have a, ICC compliant quality program? And there was a lot of confusion in there also, was it a go forward mandate or was it retroactive to all the container-based structures that were built in the past? And so two camps really emerged in the industry. One was really saying, hey, look, we should completely destroy AC 462 and bury it. And the other camp was like, look, let's give it a shot. ICC is actually giving a nod to shipping containers. Let's see if we can work with it. And we were definitely in the second camp. And so if you go in the guidelines, what you see is that the guidelines go through an exercise to actually clarify what AC 462 was meant for. So the first one is that, look, it's not meant for overall building code compliance. Just because you have an AC 462 container doesn't mean you automatically get a permit or that you are code compliant. It just means that it's establishing the physical and chemical properties of the container and nothing else, right? You still have to do all your energy calcs, you still have to do all the right framing and everything inside. And it's not meant to be retroactive either. It's only on go-forward containers. So all the different companies out there that have containers in the rental fleet, they don't have to worry about this. And then it goes through the fourth point that, look, it is the most common, but it's not the only path forward for code compliance, right? And so what we see is, and that map needs to be updated, but there are multiple state programs that have now adopted AC 462 into their state programs. So where I'm at in Texas, they definitely have given it a nod. Georgia has as well. The 4 states up to the north with Rhode Island and all that, those states have an IIBC where they all share a common modular building program. They've adopted it. Virginia has. So we're seeing more and more states really catch on to this. And so May of 2017, the first company, SG Blocks, got the first ESR related to containers. And when we saw that, them being one of our competitors, I'm like, if they can do it, well, we can do it too. So I had my engineering department come together and say, okay, how do we go about doing this? And so by May of 2018, we got the second ESR out there. And then what we did was we flew down a bunch of our competitors to Falcon, and we said, hey, look, let us teach you how to get the ESR, because a standard that's not being adopted by industry is not going to work. And so by November of 2018, a company in New Jersey, C-Box, got their ESR. And so it's been really, really cool to see this catching on. And I think there's going to be a fourth company here before too long in Texas as well that got the ESR. There are a couple of open issues with it. They've since published a revision to AC 462 where they've addressed some of these open issues. But the biggest one is, can you have a used container grow through AC 462? And so far, we haven't figured out a way to do that because of the stringent quality requirements and the traceability that you need in order to make sure an AC 462 container goes through your process. So, for us, if there are companies in California that are looking to do this and they reach out to you as far as how to go about getting their AC 462 compliance, we're happy to talk with them. But this should give you a broad overview of what a company would need to go through. In August of 2017, we kicked off the process here at Falcon. Then we had to really revamp our quality system and create a quality manual that was based on ICC AC 10, acceptance criteria 10, and their standards for a quality manual. We had to go to China, pick a manufacturer in China that could manufacture to the standards of AC 462, provide the mill certs, the traceability and all that, and also have the right surveyors surveying it. We had to train our employees because it was a different kind of material management system. And as you can imagine, containers are big materials to manage. We revamped some of our operational processes, and then we had a third-party inspector, Radco out of Long Beach, come do the inspection, and then we received our ESR. And so some of the key resources and challenge, and I think this is where a lot of you guys may come into play, selecting the container manufacturer. I think most container manufacturers in China can meet these standards, but the toughest part we found was that most of the drawings, CAD drawings and such in China are JIS, Japanese Industrial Standard, right? So translating a JIS to ASTM standard, it's not easy. It's not like 1 inch is equal to 2.54 centimeters. I think what they look for is the intent of what is being used. And here we tend to be much more empirical. There's probably a better way to say that. So we had to get our structural engineers to actually do the analysis and then tell us what in ASTM language the JIS was talking about. For smaller companies, getting a quality system in place is not easy because it's not a one-shot deal. You have to consistently manage it. You have to make sure you're on top of it. And then the fourth one, this one was fun in the sense that, from the drawings that we got from our manufacturers in China, we were able to create a design guide that we provide to structural engineers that we work with. And what it does is it goes through all the different elements of a container and talks about what the different strengths are with those different elements so that they can create like a finite element analysis and all that. So it cost us about $100,000 to really pull this off, and it took us about 8 months. But it's not impossible as a lot of the folks in the industry were thinking originally. This is some examples of the factory drawings that we're getting. I think you should be able to see that on your screen, but you can see it really gets into a huge amount of detail. It's all metric. And then from a design handbook standpoint, you can see we have the models of the different containers that we're using and how they translate into just container heights and widths. And then on the right hand there, you see, the different elements I was talking about, and then it goes through and talks about the yield points, the tensile strengths, the elongation, so on and so forth. And then from all that, we were able to get this, ours is ESR 4163. The two other companies, they have different ESR numbers, obviously. But if you Google 4163, this is available online. So key takeaway number 7 really is that there are multiple paths for code compliance, right? You could get AC 462. You could go through IBC 2021, Chapter 31. And then there's old trusted section 104.11 of the building code that allows for alternate means and methods. So in closing, the industry is definitely growing, and I think it's incumbent upon us as well as the design professionals that work with us to make sure that our products are safe when they're being used for permanent construction. And so now we have a starting framework, and I think it's our job as industry participants to actually use these codes, as flawed as they may be or as ambiguous as they may be, so that we can engage with it with the ICC in a proactive dialogue to really revise this and make it better in the years to come. So, I mean, could you imagine if the headlines, instead of what we saw in the beginning, was like container-based structures solve the affordable housing woes, especially in California. We're working on a couple of affordable housing projects out there. And it's just, I mean, the humanitarian crisis that's homelessness is pretty tragic. Or even like town center re-energized and revitalized by container parks. There are a lot of companies now looking to build container parks and food courts out of containers. Or even school overcrowding problems solved by container-based structures. I know in California, there have now been 3 schools built out of containers, and I think it's really helping because a lot of these modular units that are being used at schools as temporary classrooms, those are getting to be 40 years old or so, and they're approaching the end of their useful lives. So I think we can jump into Q&A, but here's my contact info if you want to reach out to me with additional questions. If you're shy on a web conference, I'm happy to answer any questions that you may have. Just shoot me an email. And yeah, let's, Steve, back over to you. Open it to a few more questions.
So Ali Fatah has asked, so the ESR addresses the suitability for repurposing the containers?
Yeah, so what happens in kind of practical terms is if a customer comes to us and says, look, we need to be code compliant, we will use our ESR 4163 containers. And so when that customer or their design professional goes to the building code official, they say, what's a container made out of? How do we know what the strengths are? How do you build a model around it structurally? They can take our design guide along with the ESR and say, okay, this has been passed by the acceptance criteria, and this can be used in modeling these containers.
Okay. Victor Garcia asks, do the bottom of the container support locations coincide with the locations of the lift points above, or how many more support locations are there at the base? And are there base supports at discrete locations or continuous along several lines?
So that's slightly over my head, but I would say, if you look at the strength of a container, it's all along the 4 corners. When containers are set on top of one another, the corners are slightly, they create a slight gap between the top container and the bottom container, and so all the weight's being supported by the 4 corners. As far as the bottom of the container goes, when you look underneath the container, there are floor joists about every foot, because within a container, like a 40-foot container is rated for like 60,000 pounds of cargo. So all that stuff is sitting and it's being distributed along the floor joists to those corners.
Okay, so there basically it sounds like there's 4 anchorage points. If you're going to anchor it down, yeah, you got basically anchoring down at the corner, and that's it.
Yeah.
Thank
you. That sounds a lot smarter than what I said.
Colin Foxley asks, what provisions are there for fire protection in the guidelines for IBC 2021?
Yeah, that's a tough one. Fire protection is one of those things, especially as we've started to look into multifamily construction, and no one has done fire spread tests on the walls of containers. And even though they're built all out of steel, building officials aren't willing to accept containers. I think in type 2 construction, not yet at least. And so one of the things that we've had to do is to design just demising walls for the fire partitions and fire walls just out of type X, gypsum, like a traditional method, and refer to a lot of the, the UL certified walls and go with that. But yeah, that's one that we've been spending a lot of effort trying to figure out.
Okay. Well, do we have any other additional questions that people want to type into the chat? Well, thank you very much, Stephen, for that very interesting presentation. It's been great having you here. And with that, we will conclude our webinar for the day. I'd like to invite everybody to sign up for our next webinar on November 17th. That is with Bo Dowswell, talking about the aggressive plates, the evolution of simplified design models. See, I found my notes finally. If Stephen, if you're okay with hanging on for a few more minutes, if other people want to just unmute themselves, if they got some other questions and they don't want to add it to the chat, we'd be open to that.
You bet.
Otherwise, meeting adjourned. Thank you all. Oh, Ali's raising his hand.
Yeah, thank you very much for the presentation. I work for the city of San Diego, and so we are interested in this subject. And I'm curious to see from your experience two things. One is a kind of a disappointment that where the trend is to actually fabricate containers to use as structures as opposed to reusing existing ones. Because conceptually, I thought the idea was great that you have all these abandoned containers in Long Beach. They're going back to China with merchandise, and they're sitting there. So can the acceptance criteria be used to qualify those containers, or really it would never pan out?
I think if a container has been used and it's just sitting in the ports, it's really hard to get the acceptance criteria to do it, because a couple of the standards, one, you have to go back and find the original drawings for those containers, and some of these manufacturers may not even be in business anymore. But then second, if you look at AC 462, originally they said it had to be surveyed by American Bureau of Shipping, and that was it. I think they've since added 2 or 3 more surveyors, but like if you had one that was surveyed by, let's say, Bureau Veritas or one of the other agencies, then you couldn't accept it through AC 462. But it's starting to get better. One of the solutions to that, which I don't like as much, is you can coupon those containers and figure out what exactly, and send them to a lab just to test it. But that's a little bit harder. Ali, I would say, as far as the purpose-built containers, I kind of turn my nose up at those guys, because then you're not really in the shipping container industry. You're just building big boxes out of steel.
Right, because I know that the Los Angeles Building and Safety, DSA, they have their policies, right, in writing, that allow for a way of qualifying repurposed containers. But like you say, you got to take coupon tests and things like that.
Yeah, I think DSA is a little bit harder to work with, just because they're looking out for schools, and schools built in California are notoriously difficult.
And then second question is foundation. So to provide a foundation, not to provide a foundation, especially for a 1-story, right? A lot of people don't want to put foundations. They say they're temporary. They don't want to cut through asphalt and all that. Where do you see this issue going, especially if you have utilities, hard utilities connected?
Yeah, so I mean, if it's going to be permanent construction, it has to have a foundation and it has to be anchored in some way. And if they're making the argument that it's temporary, the question that I would have is like, okay, tell me how temporary. Are you talking about temporary, like in the next 10 years that you're going to move it, or what's really going on?
Okay, thank you.
You bet. Thank you. Good luck in San Diego.
Reza, you got your hand up.
Hi, Stephen. Thanks for the presentation. So I have a question. You said that on IBC 2021, there's specification for a single unit, but how about if we have a multi-unit which is stacking on each other, or we have an elevated office, something like that? Do we have any specification regarding that, or that chapter is just talking about the single unit?
Yeah, if you look at kind of chapter 31, I'm going to turn off my screen share if that's okay. If you look at chapter 31, it doesn't give a whole lot of guidance for how to go about with a multi-unit structure. But what we've found that chapter 31 is helpful for is just to give some legitimacy to the containers so that it's not as scary to the building code officials that, hey, look, the IBC is starting to, or the ICC is starting to address containers. But with our kind of multi-unit structures, we've had to take AC 462, take the strengths that we have there and the material properties, and then build like a finite element type model.
Okay. So I'm saying, I mean, for example, if you have an elevated office, there is any, I mean, do you when you, because you have an office and you want to put it on the second floor, so you prefer to stack two offices over each other, or it's better to have elevated kind of framing and put the container on top of the frame? So I mean, that sort of thing. I mean, we want to decide which way is better. If you can stack offices over each other, or it's kind of more stable to have a kind of steel framing and put the office on top of that. So
you can totally stack these containers on top of each other. Like right now, I'm sitting in a 2-story container-based structure, right? And the containers on the bottom, where my sales team and accounting team are, they aren't even breathing hard.
yeah, but for seismic design and that sort of thing, so for seismic that they are sliding over each other, there is kind of in the container design package they already talk about this, how should kind of tie these container together if they are stacking on each other.
Yeah, so there are means and methods to doing that. There's obviously the twist lock, which is what they use in international shipping to secure the containers together on the ship. Building code officials don't like that as much because it makes it more temporary. But there are ways to weld the containers together with a plate. And I think normally for the corners we need 6 inches of continuous weld.
Okay, sure. Thank you.
Yeah, you bet.
Ready? Any other questions?
I have one.
Sure.
Oh, hi, Stephen. You showed a slide of this stadium where there were like 4 containers. Did the structure rely only on the connections between the containers themselves, or there were some additional steel members providing a lateral force resisting system? It was hard to see from the photo.
Yeah, no, so if you look at that one, there's no steel superstructure that's holding all those containers in place. They're all stacked on top of one another. The only thing is like the foundations were pretty crazy on that one. I think they're the helical piers that we had to drill into the ground on that went down, I think 20 or 30 feet because the uplift was the big concern on that stadium. I guess in Ohio they get some pretty big winds.
Uh-huh. All right. Thank you.
Yeah, my wife was terrified, Victor, when we built that. She's like, "You didn't do the calculations on that." I'm like, "I don't even know how to begin to think about calculations for something like that."
All right. Well, thanks.
You bet.
Matthew Winter, you've got your hand up.
Yeah, I had a follow-up question to the fire protection question. You said no one has a approved assembly that includes the corrugation piece, and you guys are leaning on the gypsum manual and UL listings. And from a constructability standpoint, it's obviously a little harder because you have to put gyp on both sides and lean the wall up, things like that. So I understand that no one's got that rating put together yet and fully tested. Is there manufacturers that are working on that, or has that in process, or is that something that's coming forth from anybody out there in the market?
Yeah, so I don't know what other manufacturers are doing. We've been talking with UL trying to figure it out. They told me that the testing of one assembly, just the initial fee was like $50,000, and I about fell out of my chair. So now I'm trying to get kind of an industry coalition to go in on something like that. But there aren't that many manufacturers out there that want to build container-based multi-family units just yet.
Yeah.
I think everyone's kind of on the sideline trying to figure it out. So yes, it's harder from a constructability standpoint, but I think we may have a system that works now, and we're about to put it to the test with the building department here in Texas.
Got it.
But Matthew, there are a couple of apartment complexes in Southern California that have figured it out. One of them was by Growth Point Structures, who is now been reorganized, called Crate Modular. And I think Flyaway Homes, they were just on CNN. They're out of LA and they're backed by the People's Concern. They've been able to build some multifamily there in Southern California. So somebody in California has figured it out.
Yeah, I'm actually in the San Diego. We're working with one of the. I'm an architect. We're working with one of the manufacturers. But yeah, we're leaning on the UL listings and the chipboard kind of manual and that kind of thing.
And it's pain to build, right?
Yeah, it would seem to be just to get all those 1-hour ratings and the unit to unit. But it would seem to be that there's some value into the non-combustible pieces of a container that would be able to help with 1-hour rating.
Matthew, if it's okay with you, I'll get your contact info from Bo or Steve, and I'd love to continue on that conversation, at least compare notes to see what you guys are coming up with and what our guys are coming up with.
Yeah, great.
Okay.
Absolutely.
All righty, thanks a lot. Heather, if you want to stop the recording.
Well, I can't believe this many people